Thank you for joining us today. So we're honored to have everybody. For those who are first time with our community, just a quick intro that we started 7.5 years ago as a meeting place for function as a service developers. But during COVID, we migrated to online format. So over the time, we realized that we could help businesses by working smarter, not by sprinting faster. And we started defining serverless as a pragmatic mindset, a way to focus on business value. And this loose definition of serverless allows us to explore various IT topics. So you can visit youtube.serverlesstoronto.org to check out all the educational events we curated over 7 years. And many of them are still highly relevant. And if you have good ideas for topics to cover or you want to present, mention it in the survey at bit.ly/SLSTO. We're always looking for altruistic ideas to help humanity through IT. That's what we know to do. So for example, next month, we have another very special meetup. So while everybody's bragging about their productivity hacks, and there is this boutique AI consultancy called Every.to, and they quietly transformed into product powerhouse. Their 15-person team is delivering 5 products. That shouldn't be possible. So really, and I was lucky to witness that, to adopt their software engineering methodology. They call it compound engineering. And right now I'm introducing it to Siemens. So it is so exciting to see how much better products I can create, you can create. Like I wanted to share it with you too, but from the source, from the guy who taught me. And it's a Kiran from Every.to. So if you were afraid for your job before, I promise you will discover your new superpowers after you try compound engineering. So the date is not firmed up yet. Most likely lunch and learn 19th of September. Keep coming to the group to see when Kiran will be available. And last but not the least, a big thank you to Mining Publication for supporting us as knowledge sponsor. They generously donate a title per meetup, but last time and this time they upped it. They throw 10 free copies of 2 Neo4j books. And those who don't win, Mining has provided 45% off coupon code for the digital product. So scan the barcode and enjoy the saving. And before I pass the mic to our guests, I want to explain why this topic. So we hosted what's the big deal with graph databases meetup exactly 5 years ago about Amazon Neptune, but the topic didn't stick. And it's this LLM age when graph databases resurfaced again on my radar, and I started falling for them. And we are really lucky to have Tomaž and Oskar here. They are top Neo4j powerhouses. They're really hard to book. So we need to thank again our knowledge sponsor Mining for playing a matchmaker. So Oskar and Tomaž, thank you for accepting our invitation to walk us through your new book and to introduce us to Neo4j, because there are many IT pros who never used it. So the floor is yours. Please take it away.
Hi, so thanks for introducing us. Hopefully we'll get you excited about graphs, or like just show you some other things that you could do with LLMs besides text embeddings and vector search. So I'm all for it. Oskar, do you want to briefly say something?
Yeah, really good. Thanks for having us, Daniel, in this group. Really appreciate it a lot. Yeah, I think we're good to go.
Let me open the presentation. Okay.
And it's a question at the end, or is that the format, Daniel?
Questions are at the end, so that's easier to watch on YouTube afterwards.
Yeah, perfect. Thank you.
Why are you loading? Okay, it's loaded. Yeah, so like Daniel mentioned, today we'll be talking about GraphRAG, why it's essential, because the book is called Essential GraphRAG. But let's go. Let's dive deep. Let's go into it right now. So basically, LLMs are really awesome when they work, right? You get a lot of wow moments, aha moments, but like hallucinations are still a problem, and like it's kind of tough. Like when things work on the first iteration, that's really awesome. But like if the LLM kind of gets what you want, but not completely, then it's tougher to finalize basically the task that you want to complete. So today we'll talk about a little bit about how to provide relevant context to an LLM so that the answers the LLM generates are more accurate and enhanced. So basically, this is one slideshow. Can I move this? Oops, sorry. That my Neo4j colleagues prepared. So basically, they kind of see it as we have two brains, but if you look at LLMs, they work with only half of the brain, and that's like the right part of the brain. So they're quite good at imagination, intuition, as they can write haikus, songs, and so on. But they are less good at logic, linear thinking, mathematics, facts, and so on. And as it turns out, kind of how we can say that LLM only work with the right side of the brain, and the left side of the brain is basically the opportunity for us to improve it, right? And as you can see here, it's facts. So basically it does facts, but I added a star debatable, right? Because we all know that hallucinations are the thing. So basically what it turns out, we won't go like too deep into it, but it turns out that basically what you want to do, you want to supply facts at query time to the LLM. So the LLM only interprets the provided context and the information in there, and it doesn't really, it's not dependent on its internal knowledge. Because its internal knowledge can be either outdated or incorrect, or it can simply hallucinate, right? And maybe the first architecture that we've seen with LLMs and providing extra data to the LLM via context is the kind of the vector search approach, where you take a number of PDFs, you chunk them up, you embed them and store them in a vector database. So now every database has a vector index, so it doesn't have to be vector database only. So that's the ingestion part. And then at runtime, what you do when a user asks a question, you embed the question. You use the similarity of text embeddings to find the most relevant documents. And basically you feed these relevant documents to an LLM and hope for the best, right? So this is the basic RAG approach that we've seen, and it's been kind of the hello world of the AI for the last 2 years or so, but now we've seen things are changing. But like with such a basic approach, the data model is quite simple, right? You can have a contract node. Let's say we're dealing with legal contracts, so you could have a contract node, and then we chunked the contract into multiple chunks, and we embedded those. So this is basically the data model that you're using when you're using basic or base or vanilla RAG, however you want to call it. And as I mentioned, the flow is quite simple. You just chunk the text, embed it, and then at query time, you get the top k relevant chunks using text embeddings. And what we've seen is that there's like, since the only way to retrieve information is using text embeddings, and text embeddings are great at finding similar items or similar documents. But we've seen that people want to do things that are more structured in a way, right? So, for example, if you're dealing with legal contracts, let's say you want to count how many active contracts do we have at the moment, or like how many contracts expired this month, this year, or so, or like what's the top what's the most valued contract for us, right? So these are the types of operations that text embeddings cannot handle. And for this reason, what we need to do, we need to introduce structured data, right? So because text embeddings, they work with text, obviously, but like once you want to go beyond just finding relevant documents and you want to maybe count things, you want to filter things, you want to maybe summarize, you move from unstructured text to more structured variants of the data. And basically, this is what we also try to teach you during the book. So now we had, before you saw basically the simple data model that we use for a legal domain if we only use text embeddings. And now we can walk through how this data model can be enriched and stored in a graph to kind of enhance or enrich the options and the accuracy of our question answering. So now I want to pass it to Oskar.
Yeah. Yeah. So how do we add structured data to this data model we have now? The first step we do is to actually look into the chunks into the text and look for data that we can extract, and we do that using NLP techniques, natural language processing, which is a really old expression, but has evolved quite a lot lately. So you used to be only using like specialized model for this, but now the regular LLMs can be pretty good with a lot of direction. In this case, we look into the contract, we find the parties of the contract. So we extract those as separate nodes with their names and possibly more properties. And then we add the relationship from the contract. So we bind them to the contract. So now this is the data we have now, which is, we can easily see which parties are in this contract. That's an easy query to do, which was, really hard before. And the next step after that is we can add more. We can add amendments to the contract. We can add, I think I can go to the next one even. And we can like keep enriching the data set over time as we wish. This is not something that's set up at data ingestion, but this can run as background jobs to enrich the data set over time. We can see that the party might have a CEO, headquarters, and another financial report, etc., to kind of build a model around what is this data, what are these entities, what's the context we're working in. And with that, this is what we can go to the next slide. This is what we like call a knowledge graph, where we build out the data like this. And what this gives us is interesting new properties compared to just having chunks. So if you go to the next slide, we can see that now we can ask questions. Like I said, what parties was in this contract? What are all the contracts that a certain party has, for example, which is much more precise at this point. Yeah, next one, we can see that the structured data is still linked to the unstructured data. So we know like all of these things came out of these specific chunks, which is also an interesting property, which, well, actually not in this data model, I guess, because the parties are not connected to the chunks, but rather to the contract. But in a different setup, it might make more sense to connect nodes directly to the chunks, which means that one party could be connected to multiple chunks rather than the contract. But it depends on the use case how you model this.
Yeah, maybe I also want to kind of mention here, which might be not as obvious, but GraphRAG is not competing with like base rag. So with like vector search, text embeddings only, it enhances it, right? Because you can still use text chunks, you can still use vector search on the text chunks, no problem. but you can enhance that. So you with the structured part of the data, you get, for example, I think it's more precise metadata filtering, right? So what we've seen is with vector search as well, in vector databases, they basically all support metadata filtering, because semantic search isn't really good at filtering. Like if you say, give me all the contracts from 2015, semantic search cannot do that, right? But if you have some metadata that you can filter on, basically this allows you to do that. And as I mentioned, since GraphRAG isn't competing with vector search, it's more of enhancing it. Like you could still, like in your retrieval, you could still use the base rag as your baseline and then add some additional information on top of it. Like for example, in this example, when you have legal contracts, a lot of times, basically what you get on the first page of the contract, you get some references. So let's say if it's an employment contract, so you say employee is Neo4j, but will be mentioned as employer. Employer is Neo4j, but will be mentioned throughout this legal contract as employer, and Tomaž is, let's say, employee, and will be mentioned as employee throughout this. So what we see, unless you rewrite the chunks with referenced data, you kind of lose in the context. But what you can do with this approach, you can look at the chunk, but then go from the chunk to the contract and also fetch all the related parties. So for each of the chunks, you know what the employer and the employee refers to, right? So this is similar approach. I think Anthropic called it late chunking, where they rewrite the chunks with this additional information. But since we're dealing with a graph, we can just connect relevant information and then at query time just reverse the relationship. So there's like a lot of different use cases for such a rich knowledge graph, like data representation, where you have both the structured and the unstructured data. And I feel like that GraphRAG really shines when you have multiple data sources, as showed here. So and here are some kind of pros why you want to use knowledge graph and not a lot of other things. So as mentioned, knowledge graphs are great at representing entities and relationships, but it's also what we've seen in practice. It's really nice because it's at least Neo4j is schema optional, and because with LLMs nowadays there is a lot of iterative exploration, right? And you want to add things, you want to remove things, you want to change things. So this schema optional modeling is really nice because it allows you to iterate to the different data models and different extraction pipelines really fast without having to worry about rigid schema. And another thing that's really also really nice is the multi-hop kind of efficient queries, because a lot like in this example, you might want to say, okay, let's say a CEO was in the news and something, I don't know, bad happened to this CEO, and you want to kind of evaluate how does this bad news affects us, right? So you would want to go from CEO to the party to the contract, maybe also to the chunks and to unmanaged. So you do like 1, 2, 3, maybe 4 hops. And Neo4j and Graph databases really shine when you have like a complex interconnected data. And the last one is Cypher. Basically, it's really intuitive language for writing graph patterns, because it's designed from the ground up to support graph operations, and that makes it much smoother to work with when you're dealing with relationships in your data. Okay, so now here's a little bit of thinking, but so maybe here's basically we kind of talked a little bit about why structuring data means is really valuable, right? If I go back, so basically how I see it, one half of GraphRAG is basically trying to structure your data, and you can go like from completely unstructured data to either semi-structured, where you have some values but also some free-form text, or you can go completely to the completely structured data. So how I see it nowadays, GraphRAG is basically trying to push you from unstructured data to more structured data. It doesn't have to be completely structured, but it just tries to push you along the axis to be more structured. And then the other part is basically how you retrieve information from the once you construct such a knowledge graph, and maybe I can again let Oskar talk you through it.
Yeah. So GraphRAG, the retrieval part it's not a. I guess we should have talked about this in the beginning, that it's not a one specific implementation of how to do RAG. So GraphRAG is more of an umbrella term for retrieval from something that is stored in a knowledge graph. And this is very useful in agentic systems, which has been growing quite a lot lately, where you can define a set of tools, which each of these tools could be retrieval from the graph in a different way. So this is very helpful for agents. You can define a set of tools and let kind of the agent decide which tool or which tools, I guess, are best suited to answer this specific question that comes from the user. So the traditional RAG was a pipeline of, question and using a single retriever, and then you get a response back. These agentic systems, use a question, a set of tools that can retrieve, and then usually kind of a loop where it checks like, did I get the data I wanted? If not, try again, go back and maybe rephrase the question a little bit to find new tools to get the right data. I think that's it for this slide.
Yeah, and here we have one example, like of let's say such an agentic approach of a knowledge graph. So here's like a very simple movie agent, and we'll show you a slide with patterns, but basically, like Oskar mentioned, once you go from basically, I see as base reg is more like a workflow where it's all predefined, right? You have a question, you do vector search, you get documents from vector database, feed them to an LLM, and generate the answer. So that's also like the base reg, but also base kind of workflow. And nowadays LLMs are so good. That's really nice. Like the agentic part comes out of the box from LLM providers is that we just wrap our retrievers as tools, or if you want to be like nowadays MCP tools could also make sense. And then the LLM or the agent decides which of these tools it needs to use to answer the question or solve the task. Excuse me, but also it can run multiple tools in a sequence, in parallel. It can use information from one tool output as input to the other tool. So that's the power of the agents. And what I wanted to show in this image as well is that the information doesn't have to just flow in one direction. So it's read-only. You can also store information to the knowledge graph back, right? So for example, if you had a movie agent that does recommendations, we could store, like if a user says, I already watched Top Gun, we could store the preferences back to the knowledge graph and use that as additional information for the next time when we recommend movies, so that next time we definitely don't recommend Top Gun. And here we'll briefly kind of walk you through the GraphRAG pattern. So as Oskar mentioned, GraphRAG is more like umbrella term, and there's like a lot of different data models, data approaches. Also, depending, are you dealing with like semi-structured graph, structured graph, and so on and so forth. But on a high level, this is basically the patterns that we see, and this is also the patterns that you will see in the book. And well, I can introduce maybe the most kind of mainstream one. It's the text-to-Cypher. So Cypher is the graph query language. And basically, text-to-Cypher just means that you ask an LLM to generate a cipher statement based on the input. So basically, the user asks a question, and the LLM, we feed the LLM the graph schema and the question, and ask the LLM to generate a cipher statement that would fetch information that would answer that question. And basically, that's kind of the most generic and the most flexible approach, but obviously comes with its cost, right? Because since LLMs have to do all the heavy lifting, we get slightly higher latencies and slightly lower accuracies. And now maybe Oskar, do you want to talk about your favorite GraphRAG pattern?
My favorite GraphRAG pattern, yeah. I think the fastest one I'm going to talk about, and that is the query templates, which is you know of a very valuable cipher query that, let's say you have a movie graph and you maybe use the Text-to-Cypher, and you see that it's either the Text-to-Cypher tool is not picked reliably when it should be picked, or it could be that it often generates the wrong cipher query or something like that. Then you can set up, if you set up a cipher query yourself, where you maybe have the movie title as a parameter, so it's a parameterized cipher query. It's not it's hard coded, but with a parameter. Then what you do is you let the LLM extract the data, the title in this case, and then call this function to run the cipher query, and this guarantees that the cipher queries are really fast because you set up your indexes, etc., as they to make it very efficient when you set up the database. So that's one. Another one, and there are multiple ones. I guess there are even more than we have on this slide. You can see the vector and hybrid search. We touched on this. The hybrid search is usually vector combined with full text search as well, to try out different.
Yeah, and like one thing to mention, as I mentioned before, like GraphRAG doesn't really compete with RAG, it just tries to enhance it. And even like we still use a lot of vector and hybrid search in GraphRAG patterns, especially when we're dealing with more semi-structured data, where you still have a lot of free-form text that you want to use vector search. So vector search and hybrid search is still very valuable for the GraphRAG. It's just that with base rag, you usually just embed the exact same chunk that you retrieve. But for example, what we see in GraphRAG patterns a lot of times is that people extract entities from text chunks and then they embed entities instead of text chunks. So the vector search tries to find the most relevant entities, and then from entities goes to text chunk. So it's basically like a slightly different approach than the base rag, but it still uses vector search. Yeah. And one thing I also see a lot of people doing is now community summaries are quite popular. I've been checking agentic memories, which unfortunately I don't have on this slide, but if you check agentic memory frameworks like Graffiti, Mem0, Cogni, probably some other else, a lot of those use Neo4j, but like knowledge graphs under the hood, because what we shows that base rag isn't good enough, and now you want to kind of enrich your data model, right? And that could be either through like structured outputs or like third-party APIs or so on. But yeah, basically what I wanted to say, we see a lot of also community summaries in there. So basically, as Daniel knows, it's while graph algorithms aren't as sexy as LLMs, we've seen kind of a rise of using LLMs or graph algorithms in combination with LLMs to get better accuracies. I've also seen a lot, like some like personalized PageRank for the retrieval. So there's like a lot of options, as kind of maybe implied. The space is still relatively new. Maybe GraphRAG was coined, I don't know, probably less than a year ago. So it's quite evolving, and hopefully we'll get to see more and more patterns. And I think
if you go back again, I think I want to emphasize one thing you said that is a common assumption I think people do when they say vector search. People usually think of text, that is text chunks that are embedded when you say vector search. But in a graph database, you can also do what we call node embeddings, where Tomaž mentioned entity embeddings, which is not the same. Where in embedding entities, you can embed like the properties of the entity. But with node embeddings that we have in FJ, you embed the structure around the node, so the node type and the relationships going in and out of that node. So you can find similar nodes on the structure that where it lies in the database, and not about the properties of the node, but how it lives inside.
So like I think it's called like topological information.
Yeah.
And what I've seen is also quite interesting is that people are slowly moving away from just question answering, right? Because okay, like chat with your PDF, chat with your docs, it's like, I don't know, how do I use this class in my code, right? But now people want like the databases, the graph retrievers to be more optimized. And it's like, okay, so let's say you're building like a sales agent, right? So yeah, you want to ask, I don't know, how many customers we got today, but you also want to ask, for example, which customers should we send an email to today that are most likely to convert, right? And this is where like node embeddings, graph embeddings, like Oskar mentioned, can come in handy because, for example, if you know what types of customers convert, then you could use node embeddings to find similar types of customers based on some topological information, and then direct your agent to send them emails or whatever, right? So we kind of see it as the knowledge graph. It's not just descriptive analytics, so to say what's going on, but more and more people are talking about predictive analytics, right? So that the graph can power your predictive models, so that the agent can either like autonomously fulfill, let's say, sales agent tasks or the other tasks, right? So that's quite interesting. And
we do all of these ceremonies. Sorry.
You want to talk about that?
Yes, sorry. I was gonna say we do all of this. I don't know if it's me lagging, maybe. We do all of this to get the right text into the context that we send to the LLM. That's the whole point of all this. We want to find the right data, not too much, not too little, but the right data we want. That's the whole purpose of this. I saw there was some comment in the text about what do we think GraphRAG is related to, like context engineering, and this is exactly what it is. It's to find the right context to the LLMs. And on this slide, I think roughly touched on this on the last slide, where say Text-to-Cypher is very flexible and can do anything, but could also be, providing syntax errors, etc. Whereas query templates are really fast, but they are hard coded in a sense, except from the parameters. Yeah.
Yeah. And that's it from our presentation. I hope you liked it. It was made in 30 minutes because we were then running out of time, but hope you liked it. And now we can take some of your questions.
Wow. Thank you so much. Honored to have you. So let's open the floor for Q&A. So I don't know, while people get courage to ask questions, maybe you can, Jana, you wanted to ask something.
Yes, I would have a question about the graph construction stage, because you guys talked a lot about when the graph is already there, right? How you retrieve the right information from it. And specifically, I understand that with LLMs, it's much easier to do information extraction, to extract the entities and the relationships. What about the entity linking? So when you have synonyms and different, surface forms that basically refer to the same entity, like, I don't know, Volkswagen and VW. That's just a very simple example, right? So how do you do this step? Because we find that it's a big challenge.
Yeah, I mean, entity resolution is definitely a big challenge, and it's really hard to do anything. I mean, what we've seen, like the generic approaches, is basically you kind of use text embeddings combined with LLMs to do entity resolution, but I'm not a fan of that because it doesn't really scale and it's not like the most accurate, at least from my testing. But I can basically entity resolution is like such a big field that you have companies just dealing with entity resolution, and then it could be like very domain specific, right? So how you disambiguate people's name and organization's name is very different to how you disambiguate gene names. So unfortunately, I don't have any simple answer to give you. I know I've checked now how agentic memories and like so on do it, and like I said, they use text embeddings to find potential candidates to be deduplicated, and then they ask the LLM should we really duplicate it or not. So that's kind of the most generic approach, but like I said, it can be costly because you have to ask LLM every time that it
Exactly.
wants to do
Yeah.
it or not. Right? So yeah, it's a big problem. There's no easy answers.
Okay.
It's
Yeah, that kind of.
sorry. I was gonna say it's something that we are actively working on, like knowledge graph construction from unstructured data. At Neo4j, we have people working full time on that. So we do have a open source Python library where we do a kind of primitive way of doing this, but yeah, we'll release more there, so you can keep an eye on that.
Okay, thank you.
Kunal, you have raised hand.
Yeah, hi. I have a question around performance of RAG, like GraphRAG versus base RAG. So do you have some measurable performance metrics on it, like your accuracy went up or precision recall parameters like that? Like how the performance improved from base RAG to vector RAG? GraphRAG, sorry.
I'll just say there's like one disclaimer, right? So when you want to compare base RAG to GraphRAG, your assumption is that you're only dealing with unstructured documents, right, or text, because that's the only way you can compare. So, but as I said, with GraphRAG, you can also do semi-structured and structured. So it's slightly, in a way, comparing apples and oranges. But if you check, basically, there are a couple of studies. So basically, what I've seen is a lot of these agentic frameworks that use knowledge graphs under the hood. They deal with the same kind of problem, So where you have unstructured text and you want to retrieve information from that. So now the input is unstructured text to graph and both to GraphRAG. And there are, like, for example, Mem0 published that they beat the MemGPT approach. So there are, like, the frameworks are usually the ones who are doing this comparison and benchmarks. But I don't know, Oskar, maybe you know some specific ones.
It's it's a tough one because it depends on the data and depends on the questions. So it's hard to do an objective comparison. And I think what you can do is we have a demo site where you can take some text or a web page and create a knowledge graph from that. It's not production ready, that knowledge graph. I just want to disclaimer that, but it's fun for a demo where you can create that knowledge graph. It automatically creates do the entity extraction, it does the chunking and the embedding, etc. And then you can chat with it, and then you can compare the answers that you get from regular vector RAG, GraphRAG, and hybrid approaches as well. So you can actually see the differences that come back from the LLM using your own data. I think that could be an interesting way to kind of measure that. I can paste the link.
And one thing just to mention, like I said, we don't really we're not competing with vector X. So what we've seen a lot of approaches is then just use hybrid approach. You use space vector search and you use like graph search, combine the two as a hybrid retriever, and you can use both. It should be better than just doing base RAG, right? Because when you're structuring data, basically the idea is to remove noise from the data. And when you're doing these pre-processing pipelines, you should, I mean, anecdotally, I've heard a lot of good things, but I can't this anecdotally, right?
I'll send a link to a post we have where we have some comparisons, but I'll send that as well. Thank you.
Okay,
Yeah,
you go
check it out.
next.
Thank you so much.
Oh, yes. So my question is kind of a follow-up to what Jana asked regarding entity resolution. I was wondering if there were any topology, algorithms, or if that was an approach, for actually finding similarity between nodes and being able to say, okay, this particular node is actually the same and it's just a difference of name. Let's say Jack Ma and Mayun, those are the same individuals, but they are both founders of the same company, Alibaba, and so on. Are there like topology algorithms that resolve that issue?
Yeah, so basically your approach is what I've seen is very kind of mainstream in fraud detection. And like it could be like two people have the same social security number, and like maybe address, or maybe like you said, the same like job title and such. So the idea is then you have to model your graph in a way that shared kind of personal information is stored as a node, so that then you have two people who are like you said, like presidents of Alibaba at the same time. There is a strong possibility that they're the same person. And the only problem with this approach, I mean, it's not a problem, but it's not generic, right? So you always have to check, okay, what types of data do I have available? You have to make some assumptions. So, okay, if two people live in the same place, that's not necessarily the same person. But if they have the same phone number, then it's more likely, right? And if they have the same high school, then it's very, very likely. And a lot of these entity resolution approaches are possible. It's just very hard to make them generic, right? Because it really depends on the type of the information that is provided.
Okay. Yeah, got it.
Any other question? Maybe I can shoot one. So I started using graph database in regulated industries where quality of answers is important. But like it's mostly through and fell in love with MCPs, the one you have to generate Cypher. It's just brilliant and easy for somebody who's new to Cypher to see LLM generated. And mainstream like this front runner SaaS LLMs don't have problem with that. But these regulated industries are very often on premise in the data centers. Yes, I can install Neo4j on data center, but I cannot use SaaS model from there. And so I was able only to get Kimi 2 to get reasonably good or reliably good answers like Sonnet models with that one, and was failing with Mistral, one of the models I tried. I think you were pre-training some models. What do you recommend for when you need LLM in data center that's air-gapped, that cannot go out? Like, how would you approach that situation to generate from NLP, from English Cypher?
Yeah. So in one of the teams I have, we have a Text-to-Cypher problem that we're trying to solve. So we have a lot of training data that we open source. It's on Hugging Face under the NFDA namespace if you want to fine tune your own model. In that same space on Hugging Face, we also release fine tuned Gemma 3 models, the Google open source one. That is already fine-tuned, so you can use. I think you can install that using Ulama actually and point it to Hugging Face directly. So yeah, I would try that. Like internally for our own tools, we fine-tune the Gemini models, but though obviously run in GCP.
So even for the mainstream models, you fine-tune them. I was just using whatever Anthropic gives me, and there was no problem.
At the moment, yes.
Okay.
Yeah. But that might change. They become better and better all the time. And the training data is open source, so they are also getting trained on that, I suppose.
I see. And then because Tomaž wrote another book before this one on graph data science, I noticed some of the tough questions, find criminal masterminds, find who are most risky people at risk for whatever. They are not answered by Cypher. They are answered by the graph data science library. So can you tell them when people are comparing, Neo4j is too expensive or whatever excuse is not to use it? I wouldn't compare Cypher to Cypher. I would compare with graph data science. So just enlighten people about GDS and how it can be used.
Yeah, so before I mentioned that people want to go, what we've seen is people want to go from kind of descriptive question answering to predictive. So basically you want to predict stuff based on the information that you have. And this is where GDS, Graph Data Science Library, comes into play because it allows you to do centrality algorithms, like you said, finding criminal masterminds. And you have, since criminal network is basically a network of people, right? We had this social network analysis algorithms. So basically the most kind of typical are centrality. So you find which node is the most important in this network, or you can use community detection and basically find groups of connected people. But nowadays, basically everybody wants or likes to train models. Maybe not now, but a year ago or two before LLMs came up. So, but you're not training LLMs at fine tuning. But basically, what you can do, you can build or train smaller predictive models. So, for example, you could build a random forest model. And the nice thing about GDS is the GDS allows you also to export node embeddings. And as Oskar mentioned, text embeddings, they translate text into a vector, right? Whereas node embeddings, they translate the position of the node in the network as a vector, right? So it's while on the surface it might seem look the same thing, they encode a very different information. And what we've seen is that once you have those embeddings, then people like to train their predictive models on top of those embeddings, right? Because you can use the embeddings as input to your predictive models. So yeah, maybe Oskar, if you want to say something regarding that.
No, I think you're the GDS expert here, so that's good.
Thank you. And I would encourage everybody to take a peek at that book as well. So it felt like GraphRAG was tip of the iceberg, and then I discovered wonderful land of Neo4j underneath.
Yeah, I mean, 'cause what I see as well is now with vector data, with vector search, people have become lazy. Okay, I have these documents, I chunk them up, I never look them, and I just do my base rec and hope for the best, right? But once you start to improving that, we go back to your basically data strategy, data quality. So what you do when you want to improve your data pipelines, we have to look into the data and see if it's garbage. Do we need to clean it? How do we clean it, right? And basically now that the kind of the hype died down a little bit, I guess now people are realizing that it's like garbage in, garbage out. So if you want to do just base vector and just dump everything in a single vector index, good luck, right? Maybe it's time for you to get to understand your data, and like you want to kind of define the types of questions you want to be able to answer, and so on and so forth, right? So I see it's kind of interesting for me because with AI, people just say, okay, just give it to an LLM and it will work, right? But it's not like there has to be someone who knows what's in the data, examine it, maybe do some assumptions, hypotheses. So just back the way it was before LLMs and vector databases. So your data quality means a lot, and it's just much more obvious with LLMs, right? Because now everybody wants to kind of before just data analytics, so kind of inspecting the data, the LLM access to the data, right? So yeah, clean data is critical. I agree with Richard.
Yes. So to me, like it was like another world that we did not see. I did not see for years. But looking back, like explaining to me, like how I see a graph database, this graph is like LLMs can index any book. There is so much text there. But at the beginning of every book, there is table of content. That's your graph. That's your structure, what it is. In the end of the book, you have index pointing from one place to another. Like that's what you're putting. You're putting the wiring and frame into a table of content and the index around body of knowledge. But I don't know if this makes sense or it's just me.
No,
I mean, somebody.
Oh, sorry, go on.
Yeah, I just wanted to say that basically it's I saw this one really nice marketing line, but it's basically something along the way that vector search can find your data points, and then it was graph can connect it, but then there was like graph data science can contextualize it, right? So you can go from searching data points to connecting them and then actually contextualizing them. So it is like a progression of your like data strategy. So yeah,
Is it like the wiring on top of the book? Yeah, Nikhil wanted.
No, I think one thing that the example that you gave, Daniel, and this which is going through my head. I'm a big maps enthusiast, so I think that's what occurred to me and this. Thanks for a great talk that you gave. You could, like, if you want to search for something, like search for a restaurant or something on Google Maps, right? Like you give essentially you form the sentence, you form the query in your head. That's you may call it unstructured, it is semi-structured data, but when you put it into Google Maps and it gives you all the restaurants for a particular cuisine around you, or to take it to the next step, find a distance between these 2 points, and then should I choose a hotel in this city versus that city because I'm going to go to a particular, I don't know, a resort in this town. So, and that way, essentially, you are visualizing the thing on Google Maps, and once you visualize the data in the graph fashion, you identify more patterns, and you get more insight into your results, essentially. From the starting from a very unstructured query to the results, which is very difficult to find in just a text response versus a graph response, is what is, again, I'm just trying to extrapolate that.
I love
Yeah.
the term visualize. You brought another like a messy area for me. As somebody coming new to Neo4j, there are so many ways to visualize. Like I settle with Neo4Dash, and I can build a dashboard. I don't know how to use them. Like what should we use? What should people do to properly visualize, create Google Maps kind of information on Tempora or something with Neo4j?
I think we have, well, it depends on the use case. Let's start there. And we have 3 tools ourselves that we can use to visualize. One is what we call query, which is you query it with Cypher, and then you get a visualization back if you return nodes and relationships. That's one way. That's query response. Then we have another tools that's called Explore or Bloom, used to be called Bloom, which is a full visualization tool that's more about exploring your data and filtering. So you cannot write Cypher queries there. It's about finding patterns, etc. Then we have, as you said, the dashboards, which is also part of our portal, our console, Neo4j Aura at this point, where you can create a dashboard to visualize any kind of query you wanna see, like the number of nodes or number of relationships, or alerts, or detecting things. So those are the kind of user-facing tools that we have. Then for Python notebooks, if you use that, we have a library, like a wrapper around. We have a JavaScript library called NVL. So we have a wrapper around that you can use inside your Python notebook. Oops, sorry.
And there was arrow.app also.
Yeah, arrow is very old. Yeah, but what I want to say is visualization is really powerful, right? Because especially if you're dealing with smaller subgraphs, the insights, like if you do, like, I don't know if you're familiar, but like 5 years ago or something like this, we were visualizing graphs a lot. So for example, there was the very famous Lord of the Rings graph. And they were like that. So it was very basic NLP. Basically, they took, if 2 characters in the book appear in the same sentence or so, I think it was like 13-word limit, then those 2 entities, characters are related. And you can build a graph and visualize it, and it was really popular because with smaller graphs, they're really beautiful. First of all, it's very artistic, but it gives you a ton of insights if you can visualize the whole graph. Now, the problem is that once you go beyond, I don't know, 5,000-10,000 nodes, your graph can become very messy for visualizing. So it's more like an artistic rendition than anything else. But what I kind of learned is once you go beyond like the number of nodes that you can visualize, then that's when the GDS comes into play, right? Because GDS is like graph algorithms are designed to find these interesting parts of the graph, interesting nodes, interesting communities, or so on and so forth. And yeah, it's really powerful.
There is a good question. Has anyone guidance on ETL from raw data to loaded? That was another surprise for me, positive one about real time getting data in, but you can maybe elaborate, Tomaž or Oskar, when he's back.
Yeah, I mean, so there's like a lot of variations, right? Because if you're just dealing with like, if you want to import like a relational database or JSON or CSV to your Neo4j, then what you have to do, you have to kind of design the data model of your knowledge graph and then just map your JSON CSV to that data model. That's quite straightforward. But like if you wanna start implementing like NLP, so like structured outputs where you're structuring text, then it can be slightly more, I don't want to say tricky, but more challenging, because you have to solve a bit more problems. And there's also like we said with the tools, GraphRAG tools, patterns, that we have a spectrum of like generic to specific retrievers. I feel like it's kind of the same thing with graphs. So it's really hard to build something generic that works on any data model or any data input, right? But it's much easier to build something specific, right? So for example, if I just saw example, if you want to build a knowledge graph of analyst calls and maybe combine them with SEC 10K, so this is our like financial data. If you talk with a subject matter expert who can help you understand information and model it, it's like for specific use cases and tasks, it's much easier than if you want to do something generic.
Cool. We have some more questions in the chat. Hugo is in the busy environment, so can you see in the chat? There is a lot of these frameworks. Yeah. So you see now that it's becoming popular. Everybody's me too, me too. Like, so can you tell people like this, denoise, PathRAG, LightRAG versus GraphRAG, alternatives?
Yeah, I mean, like I said, the space is very early, so there's not like a mature library just yet. I feel like, or if it is, it's hidden behind commercial, because also all these agentic memories, they have commercial offering. So they open source some stuff, but not everything. But I was looking at, I mean, GraphRAG, I think, was one of the first one, and it introduced these really nice concepts. Like, for example, before we were extracting like triples, let's say subject, predicate, object. So it's much more, I don't you lose a little bit more information, but with GraphRAG, the idea is instead of extracting like subject, predicate, object, for subject, you can also, it adds free form text to all of these three elements so that you can capture more nuanced information. So like there are pros and cons, right? So the pros are you can capture more nuanced information, but on the other hand, you have to be slightly more careful when you're querying because it's semi-structured. So it's harder to, you cannot, let's say, aggregate or count text as easy, right? But I would say GraphRAG was one of the first one, and more or less they followed the same kind of architecture. So what they do a lot of information decomposition. So what that means is for every text we extract, like I said, triples. So that would be kind of independent facts. So that's kind of the data decomposition. And then what a lot of people are trying to do is then do community summarization so that you do decomposition, but then you also go up the hierarchy and do some summaries as well. But more or less, a lot of them are doing more or less the same thing. There's like just some small tweaks. And interestingly enough, for the past couple of months, the temporal component is also really important, right? So it's not just Daniel is friend with Tomaž, but it's also from when, like, is this information still valid and so on and forth. But it's quite it's not a mature space. It's more like explorative, I would say, at the moment. So yeah.
And there is a related question. It's almost like you already said that, but make it conclusion. Michael, is GraphRAG commercial anywhere?
So when you say commercial anywhere, so is someone selling GraphRAG? So Microsoft is definitely selling GraphRAG because it's their library, right? But we've seen it's fairly straightforward to implement it in Neo4j. And I've just seen there was a Graph Summit in Chicago like a couple of days ago, and there was a company, I can't remember its name, but they said they processed 100 million documents with the GraphRAG pipeline, and they said the accuracy improvement from BaseRAG was unbelievable. So I would say, I mean, maybe like the open source development isn't like the open source development, as I see it, it's more like papers and then published code under the papers. But then that, like, how do you scale these and so on and so forth? I feel like that's hidden more behind commercial solutions at the moment. But hopefully it will be free or open source soon.
Thank you. Ukeme, you have had hands raised for a long time.
Yes, thank you, Daniel, and thank you, Tomaž and Oskar. I really appreciate this call. I had another question regarding visualizing the graph. If you speak with a subject matter expert and you have the original schema, I just want to know, is this a pattern that you've seen where the schema can evolve? Let's say you feed in more documents and the LLM can create a newer schema that is relevant to that specific industry, or is this something that is too expensive? Because let's say you have that original schema, you might lose out on new relationships that are formed when you introduce new documents. Is this a pattern, a GraphRAG pattern that you're seeing as well, or is it too expensive to have an evolving schema in that way?
I think this is just so I understand you correct. It's what we showed in the presentation, right? Where you kind of enrich your knowledge graph over time, and maybe add new node types and new relationships. So I think like building up a knowledge graph is an iterative process. Like both with data, that's kind of obvious, but even with the schema. Another, one way of knowing if adding a new relationship or adding new node types, etc., improves your application is to maybe take a subset and run, do that on that subset and then run some evaluation on it. Just check the answers. Does it improve or not?
I have a suggestion for Uma. It sounds to me like you are in the demo phase, exploring with business what models to come up with. And easiest path for me into the Neo4j was through MCP servers and Cloud Desktop that they provide, because there is a data modeling one, MCP, that can help you change the schemas, export, import, like visualize. You can do it like so. What he showed, it's a living and breathing organism that grows. But if business wants, like we are coming from relational world, so there is a schema defined, there is architect that wants a model to be seen. In that iterative phase, before the company is sold on the model, you can use the MCPs, the main one for Cypher to just generate Cypher for you to work. And then there is the modeling one, I forgot the exact name, but it gives you ability to quickly create schemas in and out for whatever use case, it's that simple. So that's how I got into the area. Like does this help or explain, Tomaž?
Oh yes, that helps. Yeah, that helps for sure. Thank you.
So the only problem, like not problem, like with me, like this year since I discovered and started playing with Neo4j, it's addictive. I'm becoming like alcoholic. So, but not everybody is using it. No, it's as in IT terms. So if you like, not many companies are using it. Like who can benefit from this? Like I know it's secret service, but they're so secret you can find them. Who are your clients? Like what field? We know fraud, we know surveillance. I see this as opportunity to build another Palantirs. Secret sauce is there. LLM, your graph databases. Like help us use you.
Yeah, we do have a lot of use cases, but we kind of identified 7, I think, as our main use cases where we can see 7 where most of our customers are, and that's yeah. I can let you know what they are. The customer graph. So this is let's say it could be a social network, it could be an e-commerce site, etc. It could be anything where you want to have. We can see could be the user journey, it could be interactions and preferences and customers, etc. To benefit from that, to where you can use node embeddings to find recommendation systems between different ones, for example. Another one is transactions graphs, which banks and fraud and all that kind of stuff definitely falls under that one. Then we have employee graph, where you kind of mimic the organization you have in a graph, so you can see and maybe add skills, etc., and tie them to people, so you can see, I want to talk to someone who knows Python. Okay, then it's easy to find who that is, right? Then we have a product graph. This one is anyone, e-commerce site or anything that has products that could be useful. It could also be used for recommendations, etc. Then a process graph could be inside a business or workflows, etc. Then we have a supplier. I think supply chain is a very common use case for Neo4j's customers, where the customers want to see where every little piece of every shipped item comes from to identify risks, etc. And what happens if one supplier goes away, or one chain, where's the weakest link. Then we have the network and security graph, as you said. So those are the main, like, large 7 graphs that we have and try to focus on.
Thank you.
I would just say I'm really a fan of digital twins.
Repeat that.
So
Fan of?
you don't hear me?
No.
Digital twin.
Digital twin.
You don't know so basically what you do. Yeah, digital twin. Yeah. Because what for me, graphs really shine where you want a complex model, complex domains, right? And you have a lot of data sources that you need to connect to so that you can kind of model like real world processes and so on and so forth. And digital twin is one of those. And then you can do all sorts of analysis, predictions, or you can just put an LLM in front of it and basically have, I don't know, someone ask questions about your digital. But basically, for me, I'm really a fan of such use cases where you need to combine multiple data sources in order to kind of get the whole context of the data, and then that gives you a ability to answer or solve complex tasks.
That's cool. So for the community, I like that. I didn't look there. Can you define digital twin for the community or whoever's watching this?
I mean, if I
what is it for you? Like, is it like we had the topic covering digital twin in context of smart cities and IoTs? That was one meetup. Like, so, but
I mean,
maybe one angle. Is it for automation in the factories?
Yeah. Basically, it can be automation factories. It could be e-commerce. It could be healthcare. It could be whatever you want, right?
Okay.
Because there's I've seen a lot of different
It's a broad term.
kinda,
It means many things to many people. So
yeah. And I mean, like I said, the nice thing is like a domain agnostic, so it doesn't really matter if you're like building aircrafts or you're building submarines or you're selling, I don't know, popcorn. The data, like the approach is fairly similar. It's very the nice thing here that graphs are very domain agnostic. So actually, the domain of your data, basically, graphs can handle any domain. Yeah.
amazing. Thank you. Next question. Okay, thank you for that link. So OSINT, yes. That's a common term, open source intelligence, not a broad term. It's thrown around graphs and databases. Can you help us? Like everything's OSINT when I Google it. Like what's really for you, OSINT?
I mean, yeah, I don't really deal a lot with intelligence and security. I know that GraphRAG guys are really big. So there's like a partner company that's now really big on working with like police and I say federal organizations to kind of help them dig through a lot of data to find criminal actors. But I'm also not familiar with open source intelligence security, so maybe that's a question for someone else.
No, thank you. Because with everything that's happening in the world, every country is increasing their security level. So graphs are there to be used, but not much is published by volunteer. We know there is I2 product. We know you are there, but we don't know much more because it's Secret Service.
Exactly.
Go ahead, guys. Any comments? We still have a couple of minutes left before the raffle. So you want to wrap up and get the free books, huh? Thank you. Thank you so much for joining us. So to make it simple, like normally we do this Wheel of Names raffle where money gives one book, but they were really good. So they gave us, last time for Jana's presentation, they gave us 10 copies of her book. Now, because there are 2 books on graph databases, and I really don't want them to use Neo4j only for GraphRAG, you have to pick up GDS knowledge, guys. So you're going to get a free 5 coupons for the GDS Graph Data Science book that Tomaž wrote, and the 5 free copies of the book that Oskar and Tomaž wrote of Essential Graph. So I will paste those in. It's first come, first serve. So good luck. If you don't win, you'll have to buy it or use 45% coupon that I shared before. So based on your preferences, it's here. Go run for it. Hunger Games.
You have to direct them. So let's give the links to the
Aha, so they know what the book. Yes, they don't even know what you. Yes, I
They
did not
don't
market
even
the
know
book
it.
properly. Do you have it?
Let me do chat. So this is the essential GraphRAG. And just a second.
I have the other one.
I
Here.
have the other one.
Yeah.
Okay.
I had that book since you published it. I never read it until like 3 months ago, when Cypher couldn't
Yeah.
help me.
So better late than never. Okay.
So that's it for me. We are almost 1:30. John, you were quiet. I hope you
Yeah,
liked it.
unfortunately, those of us in Eastern time zone have to get back to work now.
Yes. Any closing thoughts?
No, it's just fantastic session. Lots of great information. Lots of stuff that I need to go out and read and look up and become a little more smart on. But excellent talk. Thank you both presenters.
Thank you. And I'm warning everyone, it's an addictive topic, especially if you use AI as your teacher. Because you don't have to learn the Cypher, it just writes it for you, and you're learning it like a new language, thrown in a new country. Thank you, everyone. Have a wonderful weekend. Stay safe. And
thank you,
look
Daniel.
forward to another one.
Thank you.
Yes, we
Awesome.
do.
Thank you so much.
Thanks, guys. Thanks,
Okay.
Daniel.
Thank you much.